Hey, what's up guys? So today we're going to take a look at a new sample that just dropped the other day. This sample is part of our repository here on GitHub. You can access just going on this link here. And this samples, I'm very excited about this one because this is really just an example, but feel free to do what you would like. And on spectacles, and we are using in this case YOLO V8, and we are just doing this through an API call, so it's not something that runs on the device, but it's something that you call an API and the API gets you back some results, and then you play with those results in the editor and visualize things. What's important about this template, these samples, is that you will be able to understand how to project things in space, which I think that's the main contribute of this sample. And you also will have a little bit of an understanding of a typical workflow of going on Huggingface and just get a model that you think is a good model for your purpose, and then just shape it based on your needs. So in this case, what I did was going on Huggingface and finding this model, which is a great contribution, by the way, from a developer called Vaishant Ramaraj. And sorry if I mispronounce this name. But this model is quite incredible because this space shows you model at the work. The model, what it does, it detects elements. It gives you also confidence score, gives you the distance of each element, and also reconstruct in 3D part of the scene. So this is really what we need on glasses. This is not necessarily something like we can use a lot of different models as long as you have this sort of information. I think you're always going to be fine, or at least you have a very solid start to detect things. We will also go through a little bit of an understanding of how to deal with depth on spectacles. So if you go still on our template here, we explain a little bit how this works. Under the hood, what I've been doing in this template is really just like going there on that page from that developer and adding a new endpoint which provides me this data, and then spatializing our image with the detection and everything in this way. So really, this is a diagram that explains briefly what's happening. We have a camera frustum, we detect the image, we get all of these coordinates in 2D space, and then we project things in 3D space based on some, you can really guess depth as you would like. Of course, we provide the World Query model, which allows you to project things in space and understand how the space is around you. I talk to a lot of developers. Sometimes things become quite difficult when you need to have a lot of precision. But with a mix between the World Query model, projection, and some depth estimation that you might have also, not necessarily within spectacles, but also outside of spectacles, I think you can get to very good result, like this template demonstrates. I'm going to go through a little bit of a flow of how to set up this project. This is mostly an overview, it's not really a tutorial. Let's take a look at, first of all, how does it works. This is the GIF of the final demo. You will be just able to really just click a button and identify very common objects around you. These objects are also showcased, and the list of the objects that you will be able to detect is also collected in the README. So these are all of the categories that you will be able to see. Mostly I've seen it working very well on interior spaces, so your desk and things that are not too far from you, like 10 or more meters. I think when it gets too far, things get a little bit less precise, but this is a very good start. And for you to build up things that are pretty reliable and also start to mold this template for multiple purposes. So coming to the point, how does it work? So when you open this project, you will see a very simple setup, which has a DetectionManager object, and this DetectionManager object has a space here for your Huggingface API token. This Huggingface API token, of course, you need to insert yours, and then after you insert yours, things will start working. So now, without, of course, showing my token, I will just give you an example of how this works, and you will also be able to test this in the editor. You will need to go on Huggingface, and now I'm doing it with my space, but you should be able to duplicate a lot of different spaces that you would like to test, right? So this was my duplicated space, and you will need to start the space when you play with it. This space also was duplicated, but then I changed quite a lot of things. Two things in particular. The first one was to allow the space to run on GPUs. And so you can just go in the settings of your space and really trying to set up whatever GPUs you would like to use. And another thing that I added was an endpoint that would favor the use of spectacles. So if you go, when the space will start, I will show you the API endpoints. Okay, so it took a while to start the server, but the space now is officially started. You will see a lot of logs in here when you start your space on Huggingface. And I wanted to show, so this is the duplicated space. So this is no longer the space that we saw before. This is a duplicated version that I did myself. And it's very simple. You really duplicate the space. You can just right click and duplicate the space here. I put a lot of information also in the README. But the cool thing about the spaces is that there is an API that Gradio provides, and you can just hook up a lot of calls to these endpoints. So in this particular example, I created a new endpoint called getDetectionData, and these are all the data that I need to project things in 3D space. So you could really go crazy here and just personalize things as you would like with different models also, using different models, not just one. So here you can always keep open the logs. I generated a new token and I just pasted in Lens Studio. So in Lens Studio now, of course, I will be blurring out my API token. You couldn't see in this view, but if you test things in the inspector, you just had a little bit of seconds to start, and I noticed that it's better to delay when you start capturing something, because whenever you start capturing something, your hand might be in the way because you're actually pinching the button. So it's good to just delay a little bit, and then you see that you go through the logger and you see all of the logs, and then you detect things. There is a little bit of an offset on the editor. This won't happen when you are actually on the glasses. And this is just really because some camera transformations and offsets. But you see, this is the book that you see here, and this is a laptop. So the offset is consistent across the two objects in this case. You can try it in the inspector, and then when you're confident, you can try on the device. And you can also tweak a lot of values here. You can tweak the confidence thresholds, which is 0.8 here, so it's pretty high. That means that it's going to be it's going to detect just things that are pretty sure that that's the right thing to detect. My delay is 5 seconds, as you see from the countdown. The distance threshold, meaning that it's not detecting things behind 10 meters. And then we have, of course, my prefab here that is a bubble, which just said whatever this is, and then the distance, which will be still accurate, a lot more accurate on the device. So going back on the example, going back on the Huggingface space, you can see here that you can see all of the calls that you send. And I also wanted to talk a little bit about the code of this project. So let's open Visual Studio. This project at the root, don't open one thing singularly in Lens Studio every time. And then if you go on the script folder and you go on the DetectionManager, this is the main file that does most of the work. But very important, beside this one, which is the thing that organizes all of the parts of this project, a very important contribute is from these scripts. So the pinhole camera model, the pinhole capture, and the camera service. So the camera service is a way for you to get the virtual camera and get a very precise camera space and offsets between the left and the right. So you could also play with these values, not necessarily what I did, but you might be free to experiment with different things. This allows you to go from camera to screen space and so on. Then we have another thing built on top of it, which is the pinhole capture, which just allows you to have two calls, which is the capture to world and world to capture. These two methods are the most important one because they're the ones that allow you to go from screen space to world space. And this is something that it's really, really helpful, and it's the main piece of information you need just to detect things and see them in space. So this is very important. And then we have a word query model adjuster, which is nothing but once we guess this depth from those previous functions that we listed, we also do another additional check on top of it, and we just project the found object beyond that point and see actually when we are hitting something. So we are very much sure that that's the right distance. So when you will detect things, you will see just like a little bit of seconds before they place themselves perfectly in space, because there is this adjustment moment. And once again, this might be not the optimal workflow for this. keep in mind this is just a sample, and it's not running on the device. So it's really just allowing you to call APIs from any service you would like. Of course, this will need you to use the experimental API. So this was a full overview of this project. Please let me know if you need any additional information. This is available now on the sample GitHub repository. Let me know how you like it and build stuff with it. Go crazy.